This section discusses about the application of the diodes as clipper, a wave shaping ability of the diode. So, we have studied already about rectifiers and the half-wave rectifier. The half-wave rectifier is a simplest example of a diode clipper with one resistor and one diode. So, depending on the orientation of the diode, your output voltage, either the negative half cycle or the positive half cycle of the output voltage is cut. See, look at this example. As diodes positive here, when you apply this input voltage, so the positive will be passing. As considering this diode as ideal, the positive half cycle will pass and the negative half cycle will cut. So because negative half cycle, your diode will be off. So this is a simplest example of a clipper circuit. So now, normally clipper circuit we can categorize as two ways, either series clipper circuit or parallel clipper circuit. If your diode is connected in series with your input voltage, it is a series clipper. The diode is connected parallel to your input voltage, then the circuit is a parallel clipper circuit. So look at this problem. We will do this example problem for a series clipper. So here you have a clipper circuit with a diode and a series with your input voltage, and in between there is a DC voltage is provided, and you are taking your output. You are supposed to get your output across the resistor R. This is the input voltage provided 0 to 20 volt sinusoidal signal. And we are doing this problem in 4 steps. So we are doing this problem in 4 steps. So we'll start to the problem and step 1. So what's your step 1? So in your step 1, you need to find what point of your applied voltage, what point of your input voltage your diode will be on, or the transition voltage of the diode. That means a change of the state of diode will happen from off state to on state. So that particular voltage, that border voltage we need to find here. So when you think that this diode is initially off, now it is going to be on. So when it is off, what is the volt? Considering this diode as ideal, what is the voltage across the diode? Vd equal to 0. If it is a silicon, it is 0.7, or if it is a germanium, it will be 0.3. So as we considering an ideal diode over here, the voltage across the diode, Vd will be equal to 0 the moment it is going to be on. But it is just going to be on only. So still there is no current. So considering that the current, still diode is just in the open condition, the current IR is equal to, or current through the circuit, IR or whatever, only one current will flow. It will be equal to 0. So the point, the moment it is going to be on, that point the current will be equal to 0 through the circuit, as well as the voltage across the diode is also equal to 0. Vd is equal to 0, considering that diode is ideal. So now we will apply KVL in this loop. So now we are going to apply KVL in this loop. So for finding what input voltage your diode is going to be on, if you apply KVL in this loop, you see minus to plus, it is plus Vi. Now this is minus, this is plus. So it will be plus 5 volt. And what is the voltage across the diode? This considering that the voltage across the diode is equal to 0 and the current through IR is also, IR means current through the resistor. Only one current is there, understand that, because only one loop is there. So current IR is also equal to 0. So now plus to minus, this is what is your VD. So plus to minus is minus VD. Now this is current is flowing down, so plus to minus. So that means minus the voltage across the resistor. It is nothing but IR multiplied by R. So it is VR. So what is VR? VR is nothing but the IR, current through the resistor, multiplied by R. So it should be equal to 0. This is your KVL. So now you see here it is VI plus 5. This is 0. This is also equal to 0 as current IR is equal to 0. Should be equal to 0. So what is your VI? VI should be equal to minus 5 volt. VI should be equal to minus 5 volt. So at minus 5 volt of your input voltage, your diode going to change its state. Now, whether it is going to be on to off or off to on, that we need to find in step 2, depending on the orientation of the diode. So, in the step 1, we are only finding whether the diode is, at what point of voltage your diode is on or going to change its state. So now next step 2. Step 2 is we have to find in what state of the diode, because whether the diode, state of the diode for which the input voltage, whether it is positive side or negative side of input to diode, the voltage, the diode is on or that we need to find it now. So for that, you know that the diode's positive is here and the diode negative is there. So this is the anode part of the diode, this is the cathode part of the diode. So you just find what is VA minus VK. So it's just like your voltage across this diode will be equal to VA minus VD. That is what is the voltage across the diode, VD, correct? So now you see that you are here, if your VD is, as your diode is position orientation is like this, positive is this side. So you should understand that when VD is greater than your 0, you can say that diode should be on. And VD is less than 0, your diode should be off. So this is a general case I am telling, not for here, okay. So this is a normally diode is placed in this orientation. This is the case. If a diode is placing like this to your input signal, if a diode is placing like this to your input signal, biasing like this, forward bias, if it is greater than 0, diode should be on, less than 0, diode will be off. But now what about here? What is the case over here? So here if you see here, your border voltage is 5 volt, minus 5 volt, right? So in that case, when your VI is less than minus 5 volt, what will be your diode will be off. And if it is greater than minus 5, there comes the positive value. So there your diode will be on. So that is the condition over here. That is the condition here in this clipper circuit. Because why this is happening? Because of this voltage actually. So now we understand that at what voltage, exactly what voltage diode going to be on, from what voltage diode going to be on, and from which voltage diode is going to be off. So now that is clear from the step 2. So now we will be moving to the step 3. In step 3, we are taking the conditions for diode on. For the case for diode on. When diode will be on? When VI greater than minus 5 volt, your diode will be on. When VI greater than minus 5 volt, your diode will be on. So now how when I apply KVL, how it will look like? So it is equal to VI minus to plus, right? Minus to plus. So it is plus 5. Voltage across the diode, as it is ideal diode, voltage across the diode will be equal to 0. Now this is supposed to be your V out. So minus V out should be equal to 0. So this is, what is that now? Vi plus 5 should be equal to V out. Correct? So now your V out should be equal to Vi plus 5. So now just check for various values how it would be looking like. So now if you consider when Vi is equal to minus 5 volt. So what will be your output? Output will be equal to minus 5 plus 5. So it should be equal to 0 volt. Also, if your Vi is equal to 0, now what will be your output in that case? So it is 0 plus 5 is 5 volt. Also the condition you take the peak value. If Vi is peak 20 volt, what is your output? So your output will be equal to 20 plus 5, 25 volt. So now this is the case for diode on. Similarly, we need to find for the case for diode off. So that is going to be your step 4. So now in diode on, from minus 5 onwards, diode on, all these cases you understood what is supposed to be your output voltage. So we can draw that. Now step 4, we will find the case for diode off. So in step 4, you are taking the case for your diode off condition. So for your diode off, what is the condition? Vi is less than minus 5 volt. Vi is less than minus 5 volt. So when it is less than minus 5 volt, how will be your circuit? Your circuit is like this diode will be an open circuit. So current will be equal to 0 through the circuit, and you are taking your output across this resistor R, and you will apply your input here, right? So this is your 5 volt applied 5 voltage, and now you know that diode is open. The current through this circuit, the current through this circuit IR. What is IR? Circuit is open, IR will be equal to 0. So obviously here nothing but output voltage will be the voltage across the resistor. So it is nothing but IR multiplied by R, right? So that means it is 0 into R. So it is equal to 0 volt. So when the diode is off, you will get your output voltage as 0 when input voltage is less than minus 5. So now we need to plot the, already we have the input voltage provided here. So corresponding to this input voltage, now we will draw what is the output voltage. For drawing the output voltage, we have written here the condition. When input is equal to minus 5 volt, your output is supposed to be 0. So this is the minus 5 volt of input will come from here, right? This is the minus 5 volt. So in this point, what is should be your output? Your output is supposed to be 0. Your output is supposed to be 0. Now look at this. When input is 0, what should be your output? When input is 0, your output should be 5 volt. So when input is 0, your output is supposed to be 5 volt. Similarly, when input is 20, what should be your output voltage? Should be 25 volt. So input is 20, the corresponding output voltage should be 25 volt. This should be 25 volt. Okay, so it will be going like this. It's applicable here also. When input is 0, your output is supposed to be 5 volt. When input is minus 5, your output is supposed to be 0. My drawings are not good when I am drawing with this tablet. Please cooperate. So this is now 25. So it is appearing from 0 to 25 volt. This is how much? 25 volt peak. Now what about the other condition? When this is less than minus 5 volt, when your input voltage is less than minus voltage, your output voltage is supposed to be 0. Your output voltage is supposed to be 0. So this is a minus 5 volt and your output voltage is now 0. So again, from minus voltage, your output voltage will be starting increasing until 25 and then coming back. So this is supposed to be your output voltage for the clipper circuit. This is the output voltage for the series clipper circuit what you have provided. Hope you are clear with this 4 steps. So if you do these 4 steps, you are any clipper circuit comes, you can easily solve that question. Thank you.